Good morning, friends. Today we'll discuss about flat map in RDD context. And this is flat map is quite different than how do we use in Java. Because in Java, the flat map, in functional programming language jargon, the flat map method lets us replace each value of a stream with another stream and then concatenates all the generated streams into a single stream. So this is how it is defined in Java. But in RDD or in the Spark context, it's a little bit different. So it's similar to map, but each input item can be mapped to zero or more output items, but the function should return a sequence or a iterable rather than a single item. So this is the difference between a flat map and map in Spark, that it should return an iterable rather than a single value. For example, in the map that we discussed in our previous videos, that the map is a narrow transformation, which means that only it's like done for one partition, it would be mapped to another partition. For example, we have got map, and then we have got one and two objects in partition one. When we apply map, this one would be mapped to a new object, a new RDD, but with a new value of one. Similarly, for two, it will apply the map and create a new object, a new RDD with a new one. But for the flat map, is almost similar, but instead of returning only one object, it should return an iterable. So this is the difference. It would be more evident when we write some test codes. So let's write some test codes to understand it better. So I've created this unit test class for just RDD flat maps test in our chapter 7, RDD mapping. In the previous in this chapter, we have learned about RDD mapping test. So similarly, let's create a unit test, a new to unit test for flat map. So just to save some time, let me just copy this creation of Spark config. I'll copy this and paste it here. And I will, just remove this because it's local. And I will change this app name as flat maps test. Now to demonstrate this flat map, what we'll be doing is that we have got this file in resources, magnacarta.txt in a GZ format, in a zip format, and the contents of this is like this. It's a text containing a lot of lines. It's like and it's having quite a bit of text here. So our task using this flat map is that we will read this file, which is in the zip format in our resources folder, and we will count. We will just break the whole text into individual words, and then we will count the number of words, or we will also display the initial number of words. What we need to do is that we have to remove all those like spaces in between and all those like new line characters, and we only need to have just the words and store it into our RDD collection. So this is our task. Okay, so this we have already here in magnacarta.txt.gz in our resources folder. So let's read this file and count the number of words using flat map. So as we have created our Spark config here, so let's create a final try and resources block. And here I will just pass final var, which is a Spark context, which we'll create using this Spark config, Java Spark context, and we pass this Spark config. Because this is auto-closable, so we have to put it into a try with resources. It will close this once we exit out of this try block. Okay, now we need to read this magnacarta.txt.gz file. For that, I will use path. So I will just first of all, let's create this test file path. It's equal to path of, and I will just use the source test resources dot toString. So this is the path of this file, source test resources, and it's here. Now, as we have read in our previous chapters that how to read this file and digest it, so we have a Spark context dot text file method. So I will use this as the same .text file, and here I will pass our test file path. So if I do Control Alt V, it will give me my lines. So I will just mark it as lines. Okay. So this text file method we have already read before, that it's digests this and it will create a Java RDD of string, which means that the all this content in this file, this all would be treated as a huge giant string and created an RDD out of that. This is what it is doing. This string lines will be containing all the text or all the strings, all the lines which are there in that file. So I prefer to use final var here. Okay, so we have got the Java RDD string. Now our task is to find the total number of words or break this line into individual words. So let's do it now. But before that, let me just print out that what's the count of this, how many lines are there. So I'll just use printf and total lines in file. It would be lines.count. So right now, once we call this text file, sorry, I will like to reiterate it. So instead of putting like whole string into into one Java single RDD, all of these lines are created and each of them are actually put as, so it actually terminates at each of the new line character here. So each of the line would be stored here, including the blank lines here. We have got several paragraphs and we have got several blank lines in between the paragraphs. So all would be stored into this Java RDD. That's why once we put lines.count, it will give me the total number of count which are there in this file. For example, if we are just taking like these three lines here, so it would be actually counted as 3 lines here in the Java RDD. So if you take fourth, it will be fourth line like this. So each lines are separated by the new line character. And this is what we are doing it here. We read this file into this Java RDD string containing each line one by one. And if we call this count method, it will be giving me the all number of lines here. So this is one thing. Now we have got for each line now. Now let's use, just break these individual lines into like individual words. Now, if I use map and the previous map, then let's try it first. So I will use map here, and for each of the line, I will split it. So it will create a list of line.split, and the regex that I will pass is space. So by this we do it, right? So and Control Alt V again. So it will be giving me, say mapped lines. Now see here, one thing important to note here is that so first of all, when we do a line.split based on space, it will be creating an array. So that array would be, so if I do this, it will be returning a string array, right? So string array, now we actually wrap it into using this list.of, which is a static method, which will create a list out of it. Now, after doing map, so each line is mapped to a list of strings. This is, for example, let's go back here. So if we just pass this one, so that line.split, based on this, it will create 1, 2, 3, 4, 5, a string array of 5 elements here, like Carta, Magna, like this. And once we move it back to map, so it means that each line would be actually spitting out a list of string. Okay, but what we want is that we want all these lines to be mapped just to a string. We don't want to be a list of string. That's why we, instead of using map, because we are actually talking about the whole file, and we want to like break down the whole file into individual strings, not like a list of string for each line. This is what we don't want. We want actually all the words of this string, of this text, whether it's here or here, it would be all counted to like 1. So here in this case now, we will use a flat map. So let's copy this again. I'll just do this copy, and let's try to do the same thing with a map, because this map is not working as we expect. We want a Java RDD of string containing all the strings of this text. So what I will do is that instead of map, I will call it flat map. Now, once we do flat map, now it is showing me an error, right? Because as we have discussed before, that it needs an iterable rather than a single item. Right now, we are getting, for each of them, we are getting here by this context, we are getting a list of strings, right? Which is only like one item. We don't want that. We want an iterable of that. So very simple fix here. I will just use iterator, sorry. Now this iterator will return me an iterable, and now it actually, the error is gone. So it means that, let me do a Control Alt V, and then we will see that we have got flat mapped lines. Now see the difference here. We can see that now it is giving me a string, because it has actually flat map. I mean, for each of the list of strings, it has actually flattened it up, and all those lines are broken into individual words, and all the list of words are stored here in this flat map lines. So that's why in this scenario, instead of using map, flat map is the actual function that is meeting our needs. Okay, so let me separate it out, and I think we don't need this, but let's keep it there just for showing the difference. Okay. So again, I will keep it here as such, and just mark it as flat final. And now, because we have got this all this like text broken down into individual words, now let's investigate it by writing some by seeing that what's there inside it.